Hey guys, this is Mr. Sal. We're going to look at linear equations in X.
Here are the objectives and standards for lesson 3. Again, the standard is already on your cover sheet. So let's read these. The first objective: I know that an equation is a statement between two expressions that are equal, which we defined in lesson 1. And I know that the solution x to a linear equation will make the left side equal to the right side. Take a moment and write that down, please. Now let's just look at a couple examples for this. All right. So an equation would be when we have two expressions, and specifically it has to be a true statement. Otherwise it becomes a non-equation, an inequation, or more specifically an inequality, which we'll go over. However, for this one, let's just look at an example. So if I said 100 equals 100, is that true?
Yes.
Yeah, so that would make an equation. Well, what if I said 100 equals 99? Is that true? That's not true, so it would be called an inequality. But we can change this by simply adding 1 to make it a true statement. Now this is a true statement, but what if I changed it just a little bit? So I mean it looks kind of the same. 100 equals 99 plus x. Well, it's not a matter of if this is a true or not, it's what value of x makes it true. And we can see from that last example that x is 1. So for that equation, when x is 1, then it is a true statement, which would make x equals 1 a solution for that specific equation. Now if I said x was 5, that would make it a false statement, so 5 is not a solution for that equation. Alright, so let's look at this one. Is the equation a true statement when x is negative 3? In other words, is negative 3 a solution to the equation 6x plus 5 equals 5x plus 8 plus 2x? Explain. Make sure that since it asks for an explanation, to write a full sentence. Take 1 minute and do this with your neighbor. This is what the answer should look like, not only on your classwork, but we expect the answer to look like this on a test. So it asks for an explanation, so let's explain this then, okay? So I'm going to say if x equals negative 3 for the equation, then, and this is going to change the equation just a little bit, so it'd be 6x plus 5 equals 5x plus 8 plus 2x. But I left those x's blank because we're going to fill in x's with x is negative 3. So I'm replacing this x with negative 3, this x with negative 3, and this x with negative 3. So I've got my x values at negative 3. Now we're just using the order of operations to see if this is true. So I don't know it's true. I'm going to put a question mark over that equal sign, and that's what we'll solve for. So 6 times negative 3 is negative 18. I'm just using order of operations. 5 times negative 3 is negative 15. 2 times negative 3 is negative 6. Then we got the rest of this. So the whole equation right now, negative 18 plus 5 equals negative 15 plus 8 minus 6. Again, I don't know if this is true yet or not, but I can find out. Negative 18 plus 5 is negative 13. And then on the right side, I've got negative 15 plus 8, which is negative 7. And then when I subtract 6 from that, I get negative 13. So then it becomes a question of, does negative 13 equal negative 13? And the answer is yes. So that is true. So this is true. So x equals negative 3 is a solution. Does x equals 12 satisfy the equation 16 minus 1/2 x equals 3/4 x plus 1? Make sure you explain this with a full sentence. Since it wants an explanation, we want a full sentence for this. So what I'm going to do is I've got to explain this, and I'll say if x equals 12 for the equation, which we have, then, based on this equation, but again, I've left the x values blank because I'm going to replace them with x is 12. So I'm going to replace these in with 12 and solve the equation. All right, so using the order of operations on each side of this, I've got 1/2 times 12, which is 6, and 3/4 times 12, which is 9. So I've got 16 minus 6 equals 9 plus 1. And 16 minus 6 is 10. And 9 plus 1 is 10. These are equal, so I would say that is true. So x equals 12 is the solution. So x is 12 is the solution. This is what we expect the answers to look like, not only on your classwork, but on the test as well. Chat, solve the equation. 24x plus 4 plus 2x equals 3 times quantity 10x minus 1. And it's claiming that x equals 2 makes the equation true. Is chat correct? Again, make sure you explain this with a full sentence. So, we want an explanation on this one as well. So we're going to do the same thing. We're going to say if x equals 2 in the equation, then, again, it's based on the equation. We're going to write this out. And again, I've left those x values blank because we're going to replace those with 2's. So it'd be 24 times 2, 2 times 2, and 10x, 10 times 2 as well. So the order of operations on this one, some of you guys see this set of parentheses, which we do need to do first. 10 times 2 is 20, minus 1 would be 19. On the left side, we've got 24 times 2, which is 48, and 2 times 2, which is 4. So 48 plus 4 plus the green 4 there. That would be 48 plus 4 is 52. Plus this other 4 would be 56. Now this, again, we're looking at this and we're not sure yet. So we're going to say this is a question mark because we're not sure if it's equal. But it's 3 times that set of parentheses. So 3 times 19, which is 57. So does 57 equal 56? Now that is false. So we'll cross that out, the equal sign. And that makes x equals 2 is not a solution. Lisa solved the equation x plus 6 equals 8 plus 7x and claimed that the solution is x equals negative 1/3. Is she correct? Again, we want a full sentence for this explanation. It should look like the last two that we just did. Let's look at y then. So again, I'm going to say if x equals negative 1/3, and again, it's based on the equation, so x plus 6 equals 8 plus 7x, then we're going to take the equation, but we're going to be replacing the x's with that negative 1/3. Now we don't want the decimal values on this, otherwise it's going to be more of an estimation. So I'm going to keep the fractions, and I'm going to change 6 into 18/3. And 8 I'm going to change into 24/3. So that when I'm going to multiply the 7 and negative 1/3. That would be a negative 7/3. So I've got negative 1/3 plus 18/3. Does it equal, so we've got our question mark there, does it equal 24/3 minus 7/3? Now that we have common denominators, we can solve these. Negative 1/3 plus 18/3 would be a positive 17/3. And 24 thirds minus 17 thirds, this would be 17 thirds. And these are equal, so yes. Is she correct? The answer is yes. But again, it did want the explanation, which we have there. And that, well, we'll call that good. Is that Angel? Am I saying that right? Angel? Okay, whatever. Angel transformed the following equation from 6x plus 4 minus x equals 2 times x plus 1 to 10 equals 2 times x plus 1. He then stated that the solution to the equation is x equals 4. Is he correct? Let's go over this one. We're going to start with that 6x plus 4 minus x stuff first. And what I'm going to do is I'm going to move the like terms closer to each other. So instead of it reading this way, I'm going to make it 6x minus x plus 4. And that would be minus 1x. So if I had 6 x's and I subtracted 1x, then I would get 5 x's. And then I still got that plus 4. Well, that was supposed to equal 2 times x plus 1. And this is where distribution comes in. So I'm going to distribute the 2 into the parentheses 2 times x and then plus 2 times 1, which would be 2x plus 2. And again, these are supposed to be equal. So let's see if they are equal if x is 4. So I'm going to just rewrite these, 5x plus 4. But this time I'm going to say that x is 4. And 5 times 4 is 20 plus the 4, which equals 24. And again, we're looking at this equal to 2x plus 2. Now right now we don't know if this is equal, so we'll put a question mark over the equal sign and we'll replace the x with 4. Well, 2 times 4 is 8, but I still got that plus 2. 8 plus 2 is 10. So as it turns out, this is not correct. So is Angel correct? The answer is no. And our explanation is right there, because when x is 4, we get a false statement. In fact, we'll write that in, it's false. So we have our answer, is he correct, and also the explanation. Now we didn't even make it to this 10 equals 2 times x plus 1. If he used that one, it would have been true, but for the original equation, which is what we should always check our answers with, that is a false statement. So it doesn't, the second one didn't even matter in this case. Claire was able to verify that x equals 3 was a solution to her teacher's linear equation, but the equation got erased from the board. What might the equation have been? Identify as many equations as you can with the solution of x equals 3. You guys actually take a minute and try to write some equations where the answer for the equation would be, where the solution is x equals 3. Let's see, let's make one up on this. So using this 3x stuff. Well, if I had this as 3x, I can make it equal to 9, and that would work. Because now, if I replace x with 3, it'd be 3 times 3 equals 9? Question mark? Well, yeah, that's true. So this one checks off. What if we did, I don't know, something like, we'll say 4x equals x plus 9. I didn't really change much on that, but let's check and see if that works. Well, then I'd have 4 times 3. Does it equal 3 plus 9? 4 times 3 is 12, and 3 plus 9 is also 12. So yeah, that one checks off as well, so that's true. Let's look at one more. I don't know. we'll say 12x equals whatever 2, let me see, plus we'll say 34. That works. Okay, well, if I replace x with 3, then I've got x is 3 now, and I've got 12 times 3, which is 36. Does this equal 2 plus 34? Yeah, that does equal 36. So that is true. And we know that this one checks off as well. So we did 3 of them, even though, well, we could have done more. Now, we don't know exactly what equation was used for this class, but it could have been one of these 3, I suppose. Does an equation always have a solution? Could you come up with an equation that does not have a solution? Yes, we could. If we did this, so let's say that we had x equals x. Okay, that is an equation no matter what value I put in for x, but if I suddenly say, well, some value is the same value plus 3, then I can never find a value of x that will work for this. So that would be an example of it. Yeah, that works. Given that 2x plus 7 equals 27, and 3x plus 1 equals 28, does 2x plus 7 equal 3x plus 1? Well, it told us up here that 2x plus 7 is 27, so I could just replace all of this with 27. And it says 3x plus 1 is 28, so I can replace that with 28. And it's asking if this equals the same thing. Well, the answer is no. Why? Because 27 does not equal 28. Is negative 5 a solution to this equation? 6x plus 5 equals 5x plus 8 plus 2x. You guys try this one out. So we're going to take this explanation. We'll say if x equals negative 5, and we have the equation, then it changes the equation into more of a question mark equation because we're not sure if they're equal. But I would take 6x plus 5 equals 5x plus 8 plus 2x. And I've left those x's blank so that I can replace them. And we're saying in this one that x is negative 5. And then we'll see if I get 2 equal statements. All right, so 6 times negative 5 is negative 30. 5 times negative 5 is negative 25. This is just word of operation stuff. 2 times negative 5 is negative 10. So I've got negative 30 plus 5. Does it equal negative 25 plus 8 minus 10? Negative 30 plus 5 is negative 25, and we could do that with a calculator if we needed to. Then I've got negative 25 plus 8, which is negative 17. Then we still got that minus 10, which would be negative 27. So this is false. Therefore, x equals negative 5 is false. So x equals negative 5 is not a solution. There we go. let's see if this does satisfy the equation. So we will explain this one as well. So I'm going to say if x equals 1.6, and then we have the equation, then it's the same equation, but we're going to be replacing the x's with 1.6. Alright, this one has decimal, so I'm going to need my calculator for this one. Well, maybe not. 4 times 1.6, 6.4. And then I've got the division on the right side of the equal sign. 1.6 divided by 4 would be 0.4. Of course, I still got that negative in front. And we're just seeing if this is equal. So 6 minus 6.4, does it equal negative 0.4? 6 minus 6.4 is positive 0.4. Does that equal a negative 0.4? Nope, that is false. And since it is false, the answer to this question is no.
Number 4.
Use the linear equation. 3 times x plus 1 equals 3x plus 3 to answer parts A through D. So here's A. Does x equal 5 satisfy the equation above? Let's check. So I'm going to say that if x equals 5 for the equation, 3 times x plus 1 equals 3x plus 3. Then we have 3 times x plus 1, but we'll replace the x with 5. Equals 3 times 5 plus 3. We don't know if this is true or not yet, so we'll just put a question mark over the equal sign and replace the x's with 5's. So, evaluating this with the order of operations, 5 plus 1 is 6. So I've got 3 times 6, which is 18. Then I've got 3 times 5, which is 15, plus 3. Which also equals 18. So for this equation, x equals 5 is a solution. Yeah, so if x equals negative 8 for this equation, 3 times x plus 1 equals 3x plus 3. Then 3 times x plus 1 equals 3x. Let's try that again. 3x plus 3. But here we're saying that x is negative 8, so I'm replacing the x's with negative 8. Then I'll evaluate these, see if it's true. So 8, negative 8 plus 1, which would be negative 7. I'm going to multiply that by 3. So does this equal 3 times negative 8, which is negative 24, plus 3? 3 times negative 7 is negative 21, and negative 24 plus 3 is also negative 21. This is also true. So the answer to this one is yes. Negative 8 is a solution because it gives us a true statement. So is x equals 1/2 a solution of this equation? Well, let's find out. So we'll do this kind of shorthand. You know what? Never mind. We'll do it the same way because it does ask for an explanation. If x equals 1/2 for the equation, then 3 times x plus 1 equals 3x plus 3, but this time we're going to replace the x's with 1/2. I'm going to keep these in fractional form if it's necessary anyways. So on this one, first off with the order of operations, I'll do the parentheses first. Alright, by the order of operations, we'll do the parentheses first. 1/2 plus 1 is the same as 1/2 plus 2/2, which would be 3/2. So I'm going to multiply that by 3, and from this, 3 times 3 halves would give us 9 halves. And then we're going to see if this is equal to the other side of the equal sign. 3 times 1 half is 3 halves plus 3. So I need common denominators. I'm going to change that to 3 halves plus 6 halves. And this gives me 3 plus 6 is 9 halves. So this also is true.
What? Wait, is that in the paper?
One interesting fact about this equation, you guys hopefully noticed on number 4 was the same equation each time, but we had 3 separate answers which were this, which all gave us true statements. And then the question is, why do you think this is true? Here is why. It is because the equation 3 times x plus 1 equals 3x plus 3. So it's saying that if we were to use distribution on that 3 times x plus 1, well, what do we get from that? Then you got 3 times x, which is 3x, and then 3 times 1, which is 3, that's positive. It's the same thing that's on the right side of that equal sign. So it's just that it's the same equation that we're comparing for both times. They're just written differently. We've already seen an example like that, I think it was number 7 or 6, where we wrote our own equations that didn't have a solution. These ones, though, since the two sides are equal no matter what, would give us, as it turns out, an infinite number of solutions, which we'll talk about later on.
Alright, you guys, that's the end of the lesson. Thanks for watching. If you like the lesson, please leave a comment below and like it, and subscribe to the channel.